Hello, this is Mr. Frankie from Mr. Frankie Math, and if you are watching this, you're most likely one of my math students trying to learn from your mistakes on the test. So, let's get started right away. I'm going to zoom into number 1 here. Alright, if I have 4 apples for every 3 oranges, and I have 5 pears for every 2 oranges, and I have 8 apples, how many pears do I have? Well, we take a look at our proportion. Let's start with our words. We know that we're talking about apples to oranges first. And we know that if we have 4 apples to every 3 oranges, that'll tell us some things. Take a look. We have 8 apples, and then we have to figure out how many oranges we have. Well, I know that if I do 4 times 2, I can get 8. So if I do 3 times 2, it'll give me 6 oranges. Now that I know that I have 6 oranges, I can solve this next piece about finding pears and oranges combined. So let's take a look about pears and oranges. If I have 5 pears for every 2 oranges, and now I know that I have 6 oranges, I know that I can solve for the missing part of pears. So if I do 2 times 3 gives me 6, so I have to do 5 times 3 will give me this piece right here, and that answer is 15. So our correct answer for number 1 was B. Sliding over to number 2. John goes to the store, pays $43 for a new pair of jeans. If this represents 80% of the original price, what is the original price? Well, using our words first, we know that we're going to use that thing that I set up for us. We know that in a proportion or ratio that something over something will equal a percent over 100. Well, we know that John paid 80% for these jeans. And $43 represents that 80%. So what we're doing is we're trying to figure out what is this. If we cross multiply to solve this, we get 4,300. And then we divide by 80. And that'll give us X. And when you solve for this, you should have gotten a $53.75. Moving right along, number 3. This is a tricky one for a lot of students because it involves fractions and when we cross multiply. So I'm going to just do it 7 over 2 times 5 over 4 gives us 35 over 8. Now we can take that answer and divide by 5. So I'm going to show that, divide by 5. Another way to think about divided by 5 is you can actually think about it as 5 over 1. Our strategy that we use for this is 35 over 8. We do keep, flip, change. So keep the first one, normal. Flip the second one, so 5 over 1 becomes 1 over 5. And we change from division to multiplication, and then you multiply straight across. 35 over 40. This reduces, both are reduced by 5, and you get 7 over 8. And that is the letter D. Moving on to number 4. Straighten this out a little bit. Sally has a recipe that needs 3/4 of a teaspoon of butter for every 2 cups of milk. If she increases the amount of milk to 3 cups, how many teaspoons of butter are needed? Well, I would highly suggest that you guys figure out how much it costs, or how much butter she needs for 1 cup of milk. So if we set up a proportion for this, we know that we can. Here, let me just write this out. I'm going to take 3/4 of a teaspoon of butter for every 2 cups of milk. Well, I know that if Sally has 3/4 teaspoon of butter for 2 cups of milk, if I were to find 1 cup of milk, I know that I need to cut this in half. So in order to divide this by 2, I actually want to take 3/4 times 1 over 2 using keep, flip, change. And for 1 cup of milk, it means that Sally uses 3/8 of a teaspoon of butter. Now we're not done though. We need to figure out if she has 3 cups of milk. So we have to do this times 3. And that's like 3 over 1, so we get 9 over 8, which reduces to 1 1/8, which is our answer here. Number 5. This one was tricky because you had to kind of interpret some stuff from the graph. If I take a look at this time here, if this is distance on the y-axis, and this is time in seconds on the x-axis, I know that this is 0 and this is 20, but there's some lines in between. It was kind of covered up by the time. This was 5, this was 10, this was 15. So if I look at it from 0 to 5, he increases 50. So if I know that he goes 50 over 5, and then he can go 100 meters in 10 seconds. I know that he can go 150 meters in 15 seconds. If I look at all of these reduce to the same thing. He can go 10 meters in 1 second. These all reduce to 10 over 1. So Mr. Williams is fast. He's running at 10 meters per second. That's letter A. Number 6. The water level in a tank decreased from 30 inches to 25.5 inches. Find the percent decrease in the water. Well, again, we're going to be setting up a proportion here. I like to think about it as new over original. So our original level of the water was 30, and it decreased to 25.5. That original represented 100%. And what we have to do is find out what is this. So we do our cross multiplication, divide by this, and you get 2,550 divided by 30, and when you solve for that, you would get 15%. Alright, moving right along. Number 7. While studying for his math test, Javon ate 3.5 starbursts for every 11 minutes. Javon studied for 77 minutes. How many starbursts did he eat? Well, let's do starbursts over time. If we set this up, he eats 3.5 for every 11 minutes. And we know that he studied for a total of 77 minutes. Looking at this, I know I don't have to cross multiply because I know that 11 times 7 gives me 77. So I'm going to take 3.5 times 7. And if I do 3.5 times 7, I'm going to first change it into an improper fraction. So that's 7 over 2 times 7 over 1. I got 7 over 2 because I did 3 times 2, add 1. So 7 over 2. And I'm going to get 49 over 2, which reduces to 24.5 starbursts. So Javon ate 24.5 starbursts in his time studying for math. Continuing to number 8, Miss Borelli returns from her trip to England. She has 54 pounds, that's money, not weight, that she didn't use. At the JFK airport, she exchanges her pounds for US dollars. How many dollars will she receive? Setting up a proportion, I'm going to do US dollars over British pounds. I know that the scale or the currency exchange is 1 US dollar equals 0.64 pounds. And I know that she has 54 pounds with her. Notice I've kept the pounds on the bottom, pounds, 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 US dollars, and we don't know how much US dollars she's going to receive. So I'm going to cross multiply. 54 times 1 is 54. Divided by 0.64. Oops. And when I divide by 0.64, I know that that's going to be outside the house. 54 is inside the house, and I can't divide a decimal, so I'm going to move it over twice, bring it straight up to the top, and so I'm going to add my zeros, and then the answer to this one is that 64 goes into 5,400 84 times with a little bit of change left over. So she'll get $84.38. If you think about this, this makes sense. If a dollar, if it only takes 0.64 pounds to get a US dollar, we know that it's more valuable than the US dollar. So if she has 54 pounds, she's going to get slightly more US dollars for her 54 pounds because the pounds are more valuable. All right, number 9. So basketball team. This is a cool question because you kind of have to guess and judge. You had to use your brain a little bit. A basketball team, in theory, won 75% of their games. All right, which could be the number of games won by this team. So we're looking for some sort of fraction, something over something that equals 75% over 100. We're looking for something that gives you three games out of 4 won. So something here, I notice that none of these are 3 out of 4 games won, those actual numbers. Now if I look at this though, 8 games 1 to 32, well if I rewrite that as a fraction, I'm looking for something that's equivalent to 3 over 4. 8 over 32 actually reduces to 1 over 4, and I know that that is not equal to 3 over 4, so this can't be it. If I look at 21 over 32, let's see what that reduces into. Well, trying to reduce this isn't actually, 21 is divisible by 1 and 21 and 3 and 7, and 32 isn't divisible by any of that. It doesn't even reduce. So that can't be the answer. If I look at 28 games and 7 were won, 7 over 28 reduces to also 1 over 4, which is also not equal to 3 over 4. So that can't be it. Well, I haven't even found the right answer yet, but I've eliminated 3. It's most likely going to be this. Well, let's check it out. 21 over 28 does reduce to 3 over 4, so that is the correct answer. Okay, jar contains 25% green buttons, 32% yellow, 20% brown, 23% white. Total of 300 buttons in the jar. Which proportion can be used to find W? Now, this one is tough because there's all these numbers, and you have to sort through which is useful and which is not. Taking a look at this, we're looking for, we need to know the total, so that's important, and we're looking for W, which represents white buttons. So this represents white buttons. In fact, these green buttons, unnecessary. Yellow buttons, unnecessary. Brown buttons, unnecessary. So we're looking for something with the 23% white buttons and 300 buttons. So I'm going to set up my proportion. I know that I always start with 100, and we're looking for something that's 23% out of 100 because it's always percent over 100. Now, the total is 300 buttons. Not all of them are white, but I know that some of them are white. So the 300 represents the 100%, and some of them are going to be white. So I'm looking for something that's equivalent to this. And if I look at my answers here, I notice that this isn't set up normally the way that I look for it, but I'm looking for something that is close to it or equivalent to it. And if I look at these answers here, I know that this one, part C, whoops, is just the reverse. 23 is put first in W instead of X, so W is over 100 over here. So even though it's not exactly the same that we set it up in class, it is the same answer. Let's move on. Number 11, complete this table. All right, when completing this table, there's 3 parts to it. We want to figure out how much, we're finding unit rate here because it says per. So we need to find out 1 of something. So in order to find out 1 of something, I know that I'm just going to basically do this. 430 divided by 40. And when I solve for that, I get 1075. So I'm actually, this is 1075 per hour of work. I'm going to take, if we're looking for miles per hour, I'm going to take miles first, divided by hours, divided by 2.5. And I know that this is 58 miles per hour. And if I'm finding cost per ticket, I'm going to take the cost divided by 126. And that gives me $12.80 per ticket. Continuing on. Games. I'm going to shrink this a little bit here. Alright, Syracuse. Not necessarily my favorite team, but we're trying to figure out the ratio of the games they won to the total games they played. So 1 to total. So first what I have to do is figure out how many games did they win. If I count up 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 games won. To the total, well, I know that there's 1, 2, 3 games lost, and there's nothing else that I haven't touched. 9 plus 3 is 12. So there's 12 total, but we're not done yet because I know that this can reduce to 3 to 4. And that is the final answer. Number 13, Evelyn can buy 8 peaches for $4.40 or 3 peaches for $1.62. What is the unit rate for each? For unit rate, we're finding 1 of something, the cost of 1 peach. So do peach, or let's see, let's undo that. Oops. Oh dear. Moving on. So we're finding the cost of 1 peach. So I'm going to do this price over peach. How much does it cost for 1 peach? And we know that we can buy $4.40 worth of peaches for 8 peaches. When we solve this, we get 55 cents. Alright, and if I do another proportion for the other set of peaches, we want to figure out how much for 1 peach, and it costs $1.62 for 3. And when you divide 162 divided by 3, you get 54 cents per peach. Therefore, the better deal is the $1.62 for 3 peaches. Alright, moving along. Alright, a little more complicated here. We have a tax and tip, but with multiple parts. You guys have done lots of tax and tip, but let's take a look at these multiple parts. Mr. Jackson's bill was $52.50. The sales tax rate was 8%. He decides to leave a tip of 20% for the waiter based on the pre-tax amount notice as bolded. How much tip does he leave? So what we want to do is figure out if he has $52.50. And he leaves a 20% tip. The old way is you would have taken 20%, changed it to a decimal, and multiplied, and then added it. The new way that we were thinking was this. Because we know that 100% of his bill, we don't know what his total after the tip is going to be, but we do know that before his tip, he paid $52.50, and if he left a 20% tip, you add that to 100, and it's 120% of the original bill. Sorry, I just mixed these up. I apologize. His original bill was $52.50. What we don't know is what his new cost is. His original is $52.50, was 100% of the bill. If you add 20%, that's the new cost. So we're going to take $52.50 times 120 divided by 100, and you should get that his new total is, oh, you know what? I'm sorry, I apologize. I didn't read the question very closely. How much is the tip he leaves to the waiter? Well, this is real easy. I just could have just done it the original way. You get $10.50. This helps us, though, with our part 2. When you add this to the total, you should have come up with $63. But here's the deal. We're not done yet. We know that he still also has to add an 8% tax. So if we take $63, the biggest thing here that most students got wrong was that 8% is 0.08. When you solve this, this comes to 5.04. Add this to your total, and you get $68.04. Was the total bill including tax and tip. I apologize for my mistake on this one for reading it closely. Make sure that you guys are always reading your questions closely too. Number 15, how many inches are in 2 miles? Multi-step. Alright, let's take a look at this here. Alright, so there's a couple of ways you can go about this. If I know that there's 1,760 yards in a mile and he's going for 2 miles, what I might want to do is to multiply this by 2 to figure out how much this is for 2 miles. If I do this, I get 12. I get 3,520 yards are in 2 miles. And then what I might want to do is take my total yards and multiply it by 36 inches. If I do 3,520 yards times 36, I will eventually come to the answer of 126,720 inches. The other thing you could have done is gone in reverse. You could have taken 36 inches times 1,760 to figure out how many inches are in 1 mile, and then multiplied that by 2. Either way, you should have come to the same answer, which was this. Number 16. On a math test, it took Kaia 45 minutes to do 9 problems, and Tashaugn finished 18 problems in 90 minutes. Did the students work proportionally at the same rate? Here's where a lot of students got in trouble. We're looking for problems per minute or minute per problems. It doesn't matter, just as long as you keep it lined up. That's the problem, is students didn't line it up. Kaia did 9 problems in 45 minutes. What a lot of students did is they put 45 over 9 and then 18 over 90. Let's make sure that you line up your problems over minutes. What I would have done is I would have on here shown that 9 times 2 is 18, 45 times 2 is 90, or I could have both reduced to 1 over 5. Or I could have cross-multiplied. I know that either way, though, that the answer to this part is yes, they are proportional. Now, looking at this, there are 3 ways that we talked about. You can either multiply, you could simplify, or you could cross-multiply. The best method, I saw a lot of students write down the best method was cross-multiply. If you wrote down that the best method was cross-multiply because it always works, that's fine. It's true, it does always work. But what I was really hoping that you'd realize to save yourself some time was that either if you multiplied or reduced, you would have found that they both either equal 18 over 90 or 9 over 45 or both reduced to 1 over 5. That doesn't require a lot of multiplication and division using cross-multiplication. It's fast, it's quick. So I was looking for something like simplify, reduce, or to be one of your answers, and then to explain how, or how do you know. And then you would have said if you simplify, well, they both simplify into 1 over 5, or they both reduce into 1 over 5. Or if you said multiply, you said if you multiply them both by 2, then they become equivalent. Something like that. If you said cross-multiply is the best method because it always works, I can accept that, but it's just not as fast sometimes. Number 17. The best thing would have done is take this for the pages read per number of days and figure out how many pages you could read in one day. And if you figure this out, I think it comes to 73 pages in one day. So somebody can read 73 pages in one day. And if I would have reduced this, both, 657 divided by 9 gives me 73. And so then what I've done is taken 73 times 9, and I would have found that the answer for this was 949. The other thing you could have done is you could have cross-multiplied. 657 times 13 and then divided by 9 would have given you 949. Either way, you need to find 949 first if you do it that way, and then to solve for this. Then what you could have done is you could have either taken 1387 divided by 73, because using the unit rate, if I would have done 73 over 1, cross-multiply, divide by this, or I could have cross-multiplied like this, and then divided by 949. Either way, you would come to the same answer, that this is 19. So explain to me how you did it. Well, depending on your strategy, you would have either found unit rate, or you'd have shown me cross-multiplication. But your answer should have been 949 and 19. The height of a plant at the end of a month is 26 inches. If its height increased by 30% since the beginning of the month, find its height at the beginning. Again, new over original. Okay, our original was 100%. We don't know what its original height was at the beginning of the month, but we do know at the end of the month it was 26. If it increased by 30%, I'm going to add 30% to 100, so it increased to 130%. And you can simply cross-multiply and solve. X equals 20. Filling in this, a lot of students got this wrong. Okay, self-propelled lawnmower is designed to mow a half acre of land in a third of an hour. Complete all the blanks in the table. So many students did not put hours here. Please make sure you complete all the blanks. It gives you the first blank, half an acre in a third of an hour. All right. I also gave you this one right here. That was a freebie. So if I know that to get from a half to 1, I know that I did times 2. This should be equivalent. 1/3 times 2 is actually 2/3. Now, if I have to get to 1, I'm trying to figure out, okay, how do I get this? Well, if I can take any one of these, this should be proportional. 1 over 2/3 equals x over 1. Just make this an x. If I cross multiply, 1 times 1 is 1. Divided by 2/3 is the same as 1 times 3 over 2, which is 3 over 2. This answer should be 3 over 2. And then in order to get to 2, well, I can just take a look at this. I know that 1 times 2 is 2, so I should be able to do 3 over 2 times 2, which gives me 6 over 2, which reduces to 3. So your answers were 1/2, 3 over 2, and 3 hours in this blank. Taking what we know, if we know that you can mow 3 over 2 acres, or 1.5 acres, in an hour, how much can you mow in 5 hours? Well, if you know 3 over 2 acres in 1 hour, how much can you do in 5 hours? Well, I know it's times 5. So if I take 3 over 2 times 5, I know that I should be able to get 15 over 2, which reduces to 7 acres in an hour. That would be my x. All right, last of our showing of our work. A person weighs 120 pounds on Earth will weigh 20 pounds on the moon. Well, I instantly can fill that in right away. Taking the 20 pounds on the moon, find the 120 on Earth is 20 pounds on the moon. Complete the proportional relationships of the table below. Well, if I weigh 0 pounds on Earth, I'm going to weigh 0 pounds on the moon. You can't weigh, if you weigh nothing, you can't weigh something somewhere else. So 0 and 0. If I try to figure out how do I get from 120 to 60, I know I divide by 2. So I'm going to take this and also divide by 2. 20 divided by 2 gives me 10. If I take 120 and 20, how do I get from 120 to 240? Well, I know that's times 2. So I'm going to take this times 2, and that gives me 40. So your answer should have been 0, 10, 20, and 40. It says label all parts of your graph. If I label all my parts, it says Earth is the x. So I find the x-axis, and I label this Earth. Oops. Label this Earth. And I know that the y-axis is the moon, so I'm going to label this moon. And then I'm just going to, I know that on the Earth I have to go up pretty high. I have to go all the way to 240. On this, I might go by, I don't know, maybe 20s, maybe 30s. Well, let's try 30s. I'm going to go 30, 60, 90, 120, 150, 180, 210, and 240. All right, on the moon, I don't have to go as big numbers. Everything starts at 0. I'm just going to go 5, 10, 15, 20, 25, 30, 35, 40. Okay, and then I'm just going to plot my points. Everything starts at 0. If I weigh 60 on Earth, I'm going to 10 on the moon, so I go find 60, and I go up to 10, plot that point. If I weigh 120 pounds on Earth, I weigh 20 pounds on the moon, go plot that point. And then if I go 240 pounds on Earth, hefty person, up to 40 pounds on the moon. Notice, because we're working with linear stuff, it's a proportional relationship. Everything should be a straight line. All these points do go in a straight line. Draw an arrow, and the title of this graph, I'll just call it weight. Okay, so now I've completed the chart, labeled all my parts, numbers, words, drawn my arrows, connected my dots. ECRs, all right, using your rope strategy, answering this to your best of your ability. On vacation, a group of people can rent bicycles and scooters by the week. All right. It says they can get a reduced rate if they rent 5 bicycles for every 2 scooters. All right. The cost per bike is $15.50. The cost per scooter is $160. How much will they pay for 5 bikes and 2 scooters? If I do this, I'm going to take my $15.50 for part A. Actually, I'm going to just break it up into 3 parts like I normally tell you to do. Part B and part C. I know that it costs $15.50 for every bike. I'm renting 5 bikes, so I'm going to multiply. When I rent 5 bikes, that would give me $77.50. Okay? $77.50. If I have to rent 2 scooters, well, I'm going to take $160 times my 2 scooters. That gives me $320. And then all I had to do was take the total of the bikes and total of the scooters, add them together, and when you do that, you get, for part A, I'm going to extend these lines, you should have gotten $397.50. And you just said, the amount they would have paid is $397.50. I know this because I multiplied $15.50 by 5 for the total amount of bikes, and then added that to 320 because I bought 2 scooters, and when you add those 2 together, you get $397.50. Well, here's the next part. It's pretty easy. Taking $397.50 says you have to pay a 12% tax. What's your new total cost? Well, I know the 12% as a decimal is 0.12. Multiply this out. I get 44520. I think there was a couple, I don't know. Anyway, When you multiply this out, no, I apologize. When you multiply this out, I jumped ahead, you should get 4770 and 00 or something like that. And it becomes, the tax that you would add is $47.70, and then you'd add that to $397, and this is when you get $445.20. So that's the total plus your tax. The reason why I know it's $47.70 is because 12% is a little piece of the total. $397.50 is the big total, that's the 100%. A little piece would be $47.70. Add the little piece to the big piece, and you get $445.20. Part C. Alright, this is the tricky one. The group has $1,600 available to spend on bikes and scooter rentals. They have to keep the ratio of 5 to 2. So what I want to do in this last part is I know that if they have 5 bikes and 2 scooters, I know that they'll pay $397.50. Okay? But I have to include the tax too, so I know that that's $445.20. If I want to keep this proportional, my next one is going to be 10 bikes and 4 scooters, because 10 over 4 reduces to 5 over 2. So if I double the amount of bikes, I have to double the price of the bikes. And if I double the amount of scooters, I have to double the amount of scooters as well too. If I double everything, I know that I have to double the price. If I double the price, I know that I'm going to get something like, looks like $890.40. Okay? And if I'm going to do this again, if they have $1,600, they still have more to spend. Well, let's do 15 bikes and now 6 scooters. Let's see how much this costs. Well, if I add $445.20 to it, let's see how much that is. 60 cents, $5, 13.35.60. Well, that's still under $1,600, so I'm going to try again. Now, let's see if we can do 20 bikes and 8 scooters. So if we add another $445.20, here's what we get. 80 cents, 10, 8, 7, 1. Uh-oh. $1,780.80 is more than the $1,600 that they have to spend. Since that's more than they have the amount to spend, we have to go back down to the previous one, which is 15 bikes and 6 scooters. So the most they can rent is 15 bikes and 6 scooters, and then they'll have some money left over. And that's how you solve your first ECR. Continuing on, this table below, okay, this one was pretty easy. We had gone over this before. Jose, if we find the miles per hour, we just look for how far they go in 1 hour. Jose, for part A, was 6 miles per hour. Mario was 8. And Melanie was 10 miles per hour. Okay? Part B, find the distance they would travel in 7 hours. Well, you just take all of these and you multiply it times 7. And you would find that Jose goes 42 miles in 7 hours, Mario goes 56 miles in 7 hours, and Melanie goes 70 miles in 7 hours. And that's part B. Part C, you had to graph these. When you graph these, you had to label everything. It says label all parts. And so I did miles over hours. And I just did 1, 2, 3, 4, 5, and so on. For my miles, I did 5, 10, 15, and so on. And when graphing these, I would graph that 1 and 5. This would be Jose. Mario was a little faster, and then Melanie was a little faster than that. And then for part D, your answers were 40 hours, 30 hours, and 24 hours. Finally, last one right here, Kelly. This has to do with setting up currency exchanges. I know that if she has 750 US dollars, if I use my currency exchange, I'm going to do US dollars over pounds. I know it's 0.64. If she has 750, I know that that means that she has 480 pounds. If she spends 300 pounds, I have to take 480 minus 300, gives me 180 pounds. So she has 180 pounds left. Now the question asks, how many US dollars does she have left? Well, then you have to reconvert it to pounds over US dollars. We know that it's 1 US dollar equals 0.64 pounds. She has 180 pounds. How many US dollars is that? She has 281.25 US dollars. Part B. Now we're in a different we're in Spain, and if we know she has US dollars now in euros, it's 1 to 0.76, and if she has $281.25, we have to figure out how many euros she can spend. That answer comes to 213 euros and 75 cents left over, and this is euros. And finally, for part C, what I have to do is if it costs $19 a ticket, and she has 11 friends, 10 friends plus herself is 11, I'm going to take 19 times 11, and this gives me 209. The tickets cost 209 euros. I see that she has 213 euros, so yes, she has just enough money with a little change left over to take this tour with her friends. And that concludes how to do your Unit 1 final test. Please study this, students, and learn from your mistakes. Thank you.